Greetings, students. Practical 2. Now, we start by looking at your question paper there. What you are supposed to do is to evaluate maximum power transfer. And the power can only be maximum at the output, provided the output resistance is equals to the internal resistance of the circuit. What we are having here is an RL or RC or RLC circuit. But in my case, I will, on experimenting, I will ignore the 5 ohm. I'll make it 0 so that we don't come up with the same value. You have a task to work out the total impedance there in the lab that forms the internal reactance. Now, what I'm gonna proceed to now is to choose the value of the inductance. You can, if you want to use, you can use the capacitor. I'm not saying in the lab you should choose the inductance. Now, what is a value which it doesn't exist within this? I will choose, say, 0.25. If you check there, it's not in the list for possible inductance values. So I'm choosing that for you not to follow my steps. Right, students are good in emulating. So it's 0.25 I choose. Right, now if I choose 0.25, that will lead me to the value of the reactance, inductive reactance, which I have to choose for that. So I worked from the back and then coming to the front. I'll open up my calculator to check what the 0.25 will give me in terms of the reactance. So that's 0.25. And then from there is multiplied by 50 Hz and 2 pi. So 2 pi FL, remember, it's a equation for the inductance, inductive reactance. So it means my reactance there, it's supposed to be 78.5. Remember that. So 78.5 is going to be my reactance. Now, I already explained to you that I ignore the value of the resistance there. I'm not using the resistance. So now it means my internal resistance, in this case, it will be 78.5. Only the inductor, which is what is written there. Right. But you were asked to calculate the value of L after choosing. So let's say you started by choosing 78.5. Now, when you calculate, obviously, that will give you 0.25. Now, do we mention the capacitor? No, it's 0. Now, what will be the initial value of RL? It's just a rule that the internal resistance should be equal to the load resistor for maximum power transfer. It can be proved. It's a phenomena which you can prove. So then RLO, the resistance for maximum power is 78.5 or 0 dB, where there is no, it's the full scale. Right, remember those two values, 0.25 and 78.5. Now what we do is we're gonna build a circuit. In this case, I can't build a circuit. I will have to simulate the circuit. simulate the circuit for you. Right, so there is a simulation of the circuit. There is your inductor, and there's your resistor load, which is variable. The inductor is at 250, you can see there. I suppose you can. There it is, 2,5. And then the resistor at this point is not at 78,5. You can see the voltage there. It will give you less power. It's at 14,9. But remember, the voltage is going with current. It won't really matter sometimes what the voltage is in terms of the output power. Both current and voltage need to be high. So even the current, yes, it's a bit higher. We're getting around the 500 milliamps. It's moving fast. I hope you will be able to see. Right now, I will make the resistors to that 78,5 and see if the voltage will become optimum with the, as well as the current. So we go 78,5. So that's it. 79. That is closest. If you look at the voltage now, it's about 32 from 14. So there is a nice improvement in voltage there, getting about 32. And another thing, the current, it can still go up to around 500 milliamps. Around 500 milliamps. So you are looking at about 15 watts. By the way, you were asked to calculate the maximum power there. What will be the maximum power, say for 78? So you can use the V squared R formula. So which it will be half of 50 volt, which is 25 squared over 78,5. You can get that maximum power there. We can go back to that. But then, now if we calculate it from here, we're looking at around 15 watts. Right. Now, what we're going to do now is we're going to increase the resistance. The low, we can't go now. We're already coming from the low. You saw that the power is not convincing. Right there. Look at the current. It hardly goes above 150 amps. 150 milliamps, I'm sorry. So it's in fact, even 150 micro, it's in the micro range. Doesn't matter, the voltage is higher, but the current is low. So that will drop your power. So now, there you were asked to, you will have to adjust to the region where you get half of maximum power, and for both increased resistance and dropped resistance, as asked by your question. Yeah, I'm just wanted to illustrate to you that you do have increase and decrease in power based on the value of your resistance. Okay, now we can go to the question paper again. Where's our question paper? There we go. To look at other things. I won't do everything with you there, guys. There it was those exercises where you had to go to get the half of the maximum power, and then for increased resistance and dropped resistance. Just figure out how you're gonna do there. What is it that it will be necessary? But then now, remember, when you go up, the voltage will almost remain at the same place, and then you have what current will change, and then from there, quickly work out what will make the power to be half of the maximum.